Hi, this is a presentation from the COVID research group of University of Peradeniya. This presentation is about the computer vision system being developed by our research group to mitigate the COVID-19 spread. You can read more about our research group, our research and members in our website covid.eng.pdn.ac.lk. So let's start. This is a system diagram of the overall system that I am going to explain. You can see it works on video inputs, and we have algorithms in the middle, which are neural networks and other sequential algorithms, and you have outputs such as severity level reports, behavior notifications, and hotspots. Let's go into individual aspects of this system and in-depth discussions about each and every one of them. Everything starts with an input. Here we are using public scenes as our input, video feeds from public scenes. We are capturing this input by CCTV surveillance. We are using commodity CCTV cameras, which may have resolutions of 1080p or above. That is enough for our system to work. So once we acquire the video, we send them through computer vision algorithms. Mostly these are neural networks. You can see these neural networks are given in different information denoted by different colored arrows out of the video feed. So that information is encoded in a temporal graph representation. A temporal graph is a graph that changes with time. A graph by itself is a collection of nodes and edges. So these nodes and edges might have properties that change with time. Then they become a temporal graph. This temporal graph representation goes through rule-based algorithms to interpret the graph. So first we had videos that were processed by computer vision to generate the graph. Then the graph is being processed by graph algorithms to generate the outputs. The outputs can be manifold and they are useful for different types of actions in mitigating COVID-19 spread. So first let me talk about the computer vision algorithms and temporal graph representation. So this part is what we are going to talk. So let's start with the most basic computer vision algorithm, that is one that detects people. So all the people are represented as nodes in the graph. These nodes might be identical because in this step we are not going to the diversity of people, we are just taking people and representing them as nodes. But then we are going to use more sophisticated algorithms that can identify people's different properties. For example, whether a person has a mask, then these nodes are given these properties. So first it was just nodes, now they are nodes with properties. Then we have computer vision algorithms that can detect different tasks and interactions of people. The individuals becomes groups in this part. For example, talking can be represented by graph edges because that's an interaction between two people, two nodes interact and you have an edge. Even these edges might not be constant over time. They can evolve with time, they can reduce with time because these actions change in time. And then another such interaction that we can find is the group behavior. For example, if a set of people are together all the time, those things also can be represented by edges between these nodes. You can have multiple types of edges in this graph with different parameters. And then we have computer vision algorithms that can find different activities. For example, sneezing, that can be an activity of a particular person, a particular node. So those properties can also be encoded in the graph. That way we have a very informative graph that is representative of the video and what happened in the actual scene. So once we have this graph, we have to interpret that. So let me explain a few interpretations that we can get out of this graph. So we are talking about this part of the algorithm, the rule-based part, 5. So this graph can give something like a severity level report. A severity level report is actionable by an organization. For example, an organization can look at a scene and say, is this venue safe? Should we stop people from coming in? Should we limit the number of people from coming in? Because that way you can mitigate the overall COVID spread. Then we have behavior notifications, which are individual level things. For example, if a person is touching everything and we can find that, we can send him a notification. And also whether people are getting too close to strangers, those things can be behavior notifications. And then we have hotspot identification. In any venue, there are some places where there is more tendency for COVID-19 spread. So these things can be identified by processing the graph as well. So these insights can be actionable by different levels. For example, organization can action on the severity level reports, and individuals can do something on the behavior notification, and then the organization can change the physical things. For example, put red tape on a place where a lot of people try to create COVID spreading instances. For example, if there is a place where everyone goes meet and eat together, we can put a sign saying don't do that. So all these things are very actionable and has real world impact on mitigating the spread of this disease. So on summary, we are proposing this full pipeline, and we are working on different parts of the pipeline and integrating those parts together. So our pipeline starts with public scenes. We capture those videos, then we use computer vision algorithms to generate a temporal graph representation of what's happening. Then we interpret the graph to create outputs. So thank you for listening. And if you have any questions, you can contact us and ask us those questions on the website covid.eng.pdn.ac.lk/contact. Thanks for listening.